Hello everyone. In this video, we will be seeing exercise 1.3 introduction. So in the chapter introduction video, we actually studied about rational numbers and irrational numbers. Now here we will be seeing exercise 1.3's introduction, and in that we will be understanding something about decimal expansions. Now looking at the decimal expansions of numbers, we can say whether that number is a rational number or it is a irrational number. Now there are two situations in which a number can be a rational number by looking at the decimal expansion, and there is one situation of a decimal expansion wherein by looking at it we can say that that particular number is a irrational number. Now let us take an example and understand. So I'll take one example. So now say the fraction, the number 7 by 8. Now if we divide this, if we solve this, the decimal expansion what we will get is 0.875. That's it, and the number will stop here. So here it will be solved. We will get 0 in the remainder. So it will be completely solved. So 0.875 is the decimal expansion of this particular number. Now, if we see such kind of decimal expansion, then such type of decimal expansion is called as terminating decimal expansion. Why terminating? Terminating means uh, the decimals are stopping here, they are not continuing, they are terminating, they are stopping. Terminating means they are stopping. So that is why, because they are stopping, it is called as terminating, means it will not go ahead, it will stop here only, so they will get terminate. That is why such kind of decimal expansion if we see, then this type of decimal expansion is called as terminating decimal expansion. And if we see a terminating decimal expansion, then this number will be a rational number. If we have a terminating decimal expansion, then it means that this number is a rational number. Okay, now next one. One more situation for a rational number is if we have a non-terminating recurring decimal expansion. For this, I will take one example, 1 by 3. Now, if we divide this 1 upon 3, what we will get is 0.3333 like this. It will go on continuing. So here in this situation, what is happening is the decimal expansion is not terminating, it is not stopping like this situation, but it will go on continuing the same thing, 0.333333. It will continue. So here what is happening? It is non-terminating, means it is not stopping, but it is recurring. Recurring means repeating. If the same group of numbers or if the same number is repeating, then it is called as recurring. So non-terminating recurring is also a decimal expansion of a rational number. So this is another type of decimal expansion which we call non-terminating. It is not stopping, non-terminating, but it is repeating, recurring. So if we have a non-terminating recurring decimal expansion like this, then also this we can say that this particular number is a rational number. Okay, so there are two situations. Now one more example I will take here. I will take 1 by 7. Now if we divide 1 by 7, what we will get is 0.142857. And after that, again what will happen is, again the same number will repeat, again the same number will repeat. Okay, so here what is happening is exactly like here 333 is not repeating, but the numbers are repeating in group. So again after this also what we will see is 1 4 2 8 5 7. Then again after 7, again we will see 1 4 2 8 5 7. So the numbers are repeating in group. So in lot, if the numbers are repeating in lot, then instead of writing again, okay, all these numbers, what in mathematics what we do is we write a bar on this number, on this group of numbers. Then This is also an example of non-terminating recurring. So one single number is not recurring, but group of numbers are recurring. Then still this is also an example of a rational number. Okay. So such type of decimal expansions are called as non-terminating recurring because not a single number is repeating, but a group of numbers are repeating. So non-terminating recurring. So group of numbers are repeating. They are repeating, recurring, one and the same. So that is why such type of decimal expansions are also called as they come under rational numbers. Okay. Now, so this there are two situations in rational numbers. Both we have completed. Now we will see non-terminating, non-recurring. Okay, non-terminating, non-recurring. So I will take an example for this. Now, any prime number inside a square root is a irrational number. Now, if we, solve this, the decimal expansion, what we will get is 1.414, okay, 21356, okay, uh, 2, 3, and it will go on, continuing like this. It will not stop only. Okay. So if we see here, what is happening is, first of all, they are not stopping. They are not stopping. It means they are non-terminating. Then they are not repeating also, they are not recurring also. Every time, see here, 4 is there, then 1 we have 4, 2, 1, 3, 5, 6. The numbers are not a single number and nor the numbers are repeating in group. So the numbers are also non-recurring. So they are not stopping and they are not repeating. And such kind of, decimal expansions are called as non-terminating, non-recurring decimal expansions, and such type of numbers are called as irrational numbers. Okay. Now there is another example, for this example of pi. Pi is also a irrational number. Now if we, see the value of pi, it is 3.141592. Okay. 6535, and it will go on. Okay, it will go on like this only. It will not stop. So here also we can see that this decimal expansion is non-terminating, it is not stopping, and even it is not repeating. Not a single number nor group of numbers are repeating. So it is non-terminating, non-recurring, which is again a decimal expansion. This type of decimal expansion, if we have, then such numbers are called as irrational numbers. Okay. So this is what is very important, guys. You need to, understand this introduction. Okay. And I hope you have understood this. This is very important. Based on this, we have our next exercise. Okay. All right. I hope you all have understood this introduction. Guys, it really motivates me. Please like, share, comment, and subscribe my YouTube channel. And for online tuition classes, visit this website. Thank you very much, guys.